guys tomorrow. And then I think I've given you everything. I'll have to check, but August 2017, I'll open it up to you guys now, Carol. 30. This whole miles, feet thing killing you guys, huh? Fiona, do me a favor, right behind you. You have, see the pile of reference sheets right behind you? I've copied that for you and your classmates, so can you please take one and start passing them around for me before I do this problem? Please hold on to this. This is your copy now of the reference sheet. So number 30. I saw some good things yesterday, by the way, when you guys were working individually or with other people. A lot of good questions came up. I liked it a lot. So let's get those moving around here because I'm going to need everyone to look at it. We got any? We're all moving around. Okay. 2-inch grasshopper can jump a horizontal distance of 40 inches. Perfect. An athlete that's 5 feet 9 wants to cover a distance of 1 mile of jumping. All right. Here's how I saw a lot of. I'm going to do it the way I saw a lot of you do it, and you guys turned everything to inches, which is fine. All right. You turned everything to inches. So you said, all right, a 2-inch grasshopper can jump 40 inches. And then I got this 5'9" guy, girl. Sorry, I don't know which. 5 foot, he can jump, he or she can jump. Oh, we don't know. We'll have to find that. But what did you change 5 feet 9 to? 69 inches. Most people changed everything to inches. So 69 inches, how far can he jump? And why am I setting up this ratio? Because it says if this person can jump the same ratio of body length to jump length. So that's why I'm setting this up. 2-inch grasshopper jumps 40 inches. 69-inch athlete. I don't know how far they can jump. I'm about to find out, though. So you guys go ahead. You cross-multiplied. You ended up getting what? How far can this athlete jump? How many inches? 100, 192? 1,380, and this is in inches. Okay, no problem. It's in inches. How many jumps would the athlete need to take to go 1 mile? Okay, so you guys need to find out 1 mile is going to be equal to how many inches? Or look at your conversion right now. Everyone, please look at the formula sheet I have just given you at the top. You have 1 mile is 1,760 yards. Okay, that's not going to help us. But what do you have? 1 mile equals 5,280 feet. So you have choices right now. You either convert your 1,380 to feet, or you figure out how many inches are in a mile. Okay, inches in a mile. Here you go. Ready? There was what? 1 mile was equal to how many feet on your conversion chart? 5,280 feet. So what would you do to 5,280 to find out how many inches? Okay, go ahead, everyone. Multiply it by 12. There's a lot, isn't there? What was it? 60 inches. Now, what am I going to do with this? That's how many are in 1 mile, and this is how many he can do in 1 jump. I'm going to, so the number of jumps is going to be, well, 63,360 inches in a mile divided by the 1,380 he can do every jump. And now you got to watch out because it says number of full jumps, or how many jumps would it take. So 63360 divided by, what was his? 1,380. How many jumps is it going to take? Because 45 won't cut it, right? 46 jumps. That's a decent problem right there. All right. You got to find out first how many inches he can jump and then decide how you're going to convert it. Carol, you all right? Anybody else before I go on? Questions on the jumping? Okay, we're going on the 33 now, everybody. 33. Loretta and the driving. You good or? Okay. No problem. Whatever we can go over here. As intimidating as this one looks, you'll find out not too bad. I don't have to go nuts. Okay, total 610 mile total. Loretta goes, what's her speed? 55? And Dad goes 65 miles an hour. Got it? Plan, Loretta drives the first 4 hours, going what speed? 55 miles an hour. So that tells me 55 miles an hour for 4 hours. That'll tell me how far do they go. Right? 55 miles every hour for 4 hours. Her dad goes what? 65 miles per hour, but I'm trying to determine the number of hours it'll take after Dad takes over here. So I have no idea the number of hours he did. That's what I'm going to solve for. But I do know once she drives and he drives, the total distance is going to be what? 610 miles. Now, did you have to set up an equation? Absolutely not. You don't have to. Right? You could have just multiplied 55 times 4, moved it over like I'm going to here, but that's 220 plus 65x equals 610. Move the 220 over, you get 390. And here was the key I think a lot of you may get caught up on. You solve 6 and you're like, done. I solved for x, I must be done. Because anytime I solve for x, I must be done with the problem. What is x now? That's how long the dad drove. What's the question ask? Number of hours it'll take the family to reach their destination 610 miles away. So it took the dad 6. How long did Loretta drive for? 4. So it's a total of 10 hours. We all good there? We sure. Don't forget to add in the 4. I know that's a simple point off right there. Okay, you ready for the second part? Okay, instead, Loretta's only going to go 2 hours now. So 55 times 2 plus 65x. Don't know what the dad did, but I still know they went 610. How much time are they going to save now? From their originally 10 hours, how much time are they going to save? So I'm going to do the exact same thing. But at the end, I'm not going to add 4. No, I'm not going to add 4 at the end. Because what's Loretta doing now? 2 hours, so I'll add 2 to it, and then I'll subtract the 2 hours there. Okay, so let's keep going. So I got 110 plus 65x equals 610. Move the 110 over. 65x equals 500. Okay, and then x is this long decimal, which I'm not going to round. I'm going to keep it. 0.69230769. Again, what is this representing? Anybody, what's that x representing? That's the time the dad drove. Loretta, though, drove how many in this case? 2, so I still have to add the 2 in. So this trip took them 9.69230769. What's the question asking? How much time they saved. So what am I going to do with that 9.69? Subtract it from 10. So time saved will be 10 minus, right there. and then round it to the nearest tenth of an hour. And I believe you get 0.3. So they say 0.3 hours, a third of an hour. AKA how many minutes? If it asks minutes, maybe a third of an hour. Actually, that's not a third of an hour. That's 3/10 of an hour. So whatever 3/10 times 60 is. It's not a third. Get your act together. All good? Okay, perfect. More? Anything more here before I get into mine today? Because I am going to do a couple problems with you. Hey, just a quick, while we're here, no one's going to ask me about it, so I'm not going to do it. You can always come to a review session and ask me, though. The whole frequency table deal. I got to remind you, when you do the table, when you do the graph, it's got to be in what? Pencil, pencil, pencil. Hey, ready? Focus it. Pencil, pen. The only actual thing that has to be in pencil is the physical graph. Any work around it, with it, needs to be in pen. Okay? Make sure, again, what should go on your, other than your, these cute little woo bars here. Yep. And by the way, if that looks like that, I don't know what you're doing in the exam. I really don't. Okay? Because I could get my daughter in here and do the same thing, and she's 3. Labels, correct? Yes. Labels, title, label, label. Did this one require, let's see, where'd your Y's? At 6, so I guess not. But what say, for instance, I'm preparing you for every scenario. Say, for instance, this first interval was 40.0 to 40.1. Anybody know what I would require right here? The break. If it's not, if your first interval is not close to 0, you need a break in there. Okay? If it's not anywhere close to 0, you need a break in there. All right? No other questions before I get into mine. Emma, go.
Wait, so you don't need a break, like, because I started mine right at, like, that part with 6 to 6.1, but would I need a break?
You would well, here's the thing, though. You got to make sure you go by equal intervals.
And I didn't. I just started at 6. And then I just kept counting.
I think that would be fine. 6 is pretty close to 6. But like I said, if it starts at 40, something much larger, then you're going to need a break. And also, last thing about these histograms, make sure the width at the bottom is the same number of units. You can't have one of 2 and then 8 and then 5. All right, make sure they're all the same width. All right, let's go here. The grind is real here today. 35, let's go. 35. Oh boy. There's just to me, there's certain things on here that we have to get correct if we want to do well. This is one of them. Graphing inequalities. Don't do a darn thing. Don't touch the paper. No pen to paper. Inequalities. 2 things you got to worry about before you even start it. 2 things to keep in your mind when you graph any inequalities. We talked about it. Come on. Matt? Dash or solid. Correct. Next thing you got to worry about. Callie? Shading. Perfect. Dashed or solid line, shading. Before you even start, keep that in your mind. Look at the inequality symbols. Am I going to have dashed, solid, or a combination of both? 2 dashed, because there's no or equal to. So if you want to write that off to the side to remind yourselves, darn it, I need a dashed line in there. Okay? The work you do right now is in pen. And I don't care right now, but test day, Tuesday, is in pen. When you go to do the dash lines, they're in pencil. Okay, I just don't want to answer these questions over and over on Tuesday. All right, let's start with this first one here. 3x plus 4y is greater than 20. I need your help getting it into y mx plus b form. First step, move over what? Move over the 3x. How? Subtract the 3x over. Y, 4y, greater than negative 3x plus 20. I always like the x to come first. Next step, what would you like to do to get the y by itself? Divide both sides by 4. So the first one we're going to graph is y is greater than negative 3/4 x plus what? Each one gets divided by 4. By 5. Okay, we're going to stop there and we're going to graph that one first before we transform the second one. All right, here's where I get a little nervous because you just finished a frequency histogram and they set it up like that. Is that something I need here? No, I do not want to set it up like that. If you're going to graph anything, I need your usual XY axes drawn in. So go ahead, draw it in here. I got to go over to my laptop and do this because I can't see a darn thing with these lines. So draw in your XY axes for me. Okay, graphing now. Where's my first? You do not need a table. Remember, if you're graphing a line, you do not need a table, but you can use one. All right, you can use one if you need one, but where's this going to start? What's my y-intercept? Positive 5. So everyone ready? 1, 2, 3, 4, 5. There's my first point at 5. Oh, I don't need that big. Man, I don't need that big. There, that's good. And then from here, where can I go? What's the slope of this line? So I can go either down 3, right 4, or I can go up 3, left 4. You decide. It should be going down, though. Okay, so up 3 to the left 4. 1, 2, 3, 4. Or again, I can go down 3. 1, 2, 3 to the right 4. 1, 2, 3, 4. And you guys told me what type of line should I be graphing in? Dashed, straight edges, brought to the exam. And Callie, remind your classmates, what else do I have to worry about? Shading. Test 0, 0, what do you think? Test 0, 0? Is 0 greater than negative 3/4? This is going to be times 0 plus 5. Is this true or not? What do we think? True or not? Is 0 greater than that? No, that means 0, 0 is not a solution to this one, so I'm going to shade away. Yes, above in this case. Also, I'll mention this. If anybody's a colored pencil highlighter person, those are allowed. So if you want to bring a couple of colored pencils with you or highlighters for a shading one like this so you can see where they overlap, I'm good with that. All right, it is allowed. Just make sure you shade in the right direction because I cannot give you an extra test. Jack, how we looking, all right? Darn right you are. All right, next one. X is less than 3y minus 18. Can I get a little help from you guys? What do you want to do on both sides? That's what I was thinking. Yeah. X plus 18 is less than 3y. And then divide by 3. Ooh. Whoa, what happens here? Okay, I would prefer you guys write as 1/3 because that's going to be easier when you graph instead of x over 3. So 1/3 x plus 6. Everyone all right so far? This is an easy 4-pointer here for us, hopefully. Easy 4-pointer if we just take our time, be neat, have some self-respect, care a little bit for the 2 to 3 hours you'll be there. Okay, where do I start this graph? I'll do this one in orange. +6, so right above the 5. And then where do I go from here using the slope of 1/3? Up 1, 1, 2, 3, up. Or I could go down 1, 1, 2, 3. Another dashed line. Did I do that? Up 1/3, down 1? Yeah, I guess so. We are looking magical. Now I got to test 0, 0. Are everyone ready? 1/3 times 0 plus 6. Is that less than 0? Oh, how about I put in the 6 here? It looks like now this looks like my daughter's actually writing this, yes. Is that a true statement? Is 6 less than 0? Nope, so I got to shade where? Away above that line, yep. So let me get a new color here. We'll go to green action. Shade away from 0, 0. So does everyone see where our solution's going to be here? Put a big S right now. Go ahead, label your solution S. It's the intersection of the shaded regions. What? You could, yes. So you're saying is 0 less than -18? Which it's not, so it's still a no. Yep. Emma.
When you label, do you use the original equation?
I haven't gotten there yet, but thank you for stealing my steam. I was about to say that as beautiful as this looks and yours looks, I got to take a point off. How many graphs are on here? 2. Anytime there's 2 graphs, you have to at least label 1. And to answer your question, Emma, it does not matter if it's the original or the converted one. Okay, at least 1 line needs to be labeled. If you want to go both, you can go both. That's up to you. Let's see, this was x less than 3y minus 18. There you go. At least one's got to be labeled. Is there a secondary question to this? Of course there is. There always would be. And I cut it off. Calm it down. Is the point 37 in the solution set? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. This point on the line, right? Okay, let's talk here. Is that point on the solution set or not? If it's on the line. Everyone ready? What type of lines did I draw? Dashed. All right, if it's on a dashed line, it is not part of the solution set. Okay, if it's on the dashed line, it is not part of the solution set. It's got to be actually in the shaded region. The only time, the only time I would say yes when it's on the line is if both lines are shaded. Shaded. Both lines are solid, and it's the point of intersection. I could care less. Ready? Let's say this line was now solid. That's still not a solution. It's got to be at either the point of intersection of 2 solid lines or in the shaded region. Let me say that one last time. If a point is in the solution set, it's either got to be in the shaded region or the intersection of 2 solid lines. Okay? I don't care if this line was solid or dashed. It doesn't matter to me. If it's not the point of intersection, it's not a solution. Okay, for inequalities only. Caitlin.
But if it's a solid line, why would it?
Because it's got to work in both.
But like if they were both,
That's what I'm saying. If it's the point of intersection of both and they're both solid, yes, it's a solution. But see, 3, even if this line was solid, 3, 7. Not in here. See what I mean? Okay.
So like, it'd probably be better just to put it in there.
And that's what I was going to say at the end. I know this is probably confusing to many of you. Worst comes to worst. You know what you do with 3, 7? 3, 7. Does it work? 3, 7. Does it work in both? Done. Okay, that's the easy way out. Don't even honestly, I wouldn't even bother looking at the graph and being like, solid dash. What did he talk about that Thursday? It was so confusing. Plug it in and see if it works in both. Easy way out. Easy way out. Go ahead, Emma.
So for the labeling, if you labeled one line and you got it wrong with the wrong equation that you did, would you get all the points?
No. No.
So like it wouldn't make a difference if you wrote the original one or the wrong one?
Nope. Okay, we all good there. Whew. So you see what I'm saying with if a point is a solution or not, just plug it into the equation. Don't worry, don't look at the graph. All right. Cruising altitude, here we go. Oh, yep. Air Force pilot, 36. Nobody touch your calculator. What's this going to be a graph of? What do we call it? Parabola. Is it going to open up or down? Okay, hopefully we're at that point now. Okay, parabola opening down. At least you get a visual of what it's going to be. State and determine the vertex. And I can tell you, going to the calculator probably won't help too much here. 9,000, you'll be doing a lot of clicks to get there. A lot of clicks to get to there. How do I find it algebraically? We talked about this the other day. What does the x coordinate of your vertex represent? I got a vertex, right? It's going to be x comma y. What's the x coordinate represent? That's another name for your axis of symmetry. How do I find it? All right, here we go. You don't need a darn calculator for this one. B value in this equation, B value, 128. So when I plug it in, negative 128 over 2 times, how about your A value? Negative 16. All right, everyone, find the x coordinate, or AKA the axis of symmetry. Guys are doing a nice job here. Axis of symmetry, 4. So I know the vertex is going to be 4 comma something. How do I find that something something? Store. Store 4 in for x. Or t, if you want to store it in for t, because the equation's in t, your call. Type in the equation. And you guys tell me what you end up with for a y value. Ooh, boy. $9,250. Make sure you can get that on your calculator right now. Just don't copy it down. Can you get it? Because you're on your own Tuesday. Don't call me over and, how did you show me to store? Where's my fraction template? I'll just one big smile and pat you on the back and say, good luck, kid. Good luck to you. And what I mean is not on the test. I just mean in life. Okay? So there's a secondary part, though, and I'm not talking about this secondary part. You found the vertex. Explain what that second number means as far as the problem goes. Okay, okay, hold on. After for what? After 4 seconds, the pilot's height is 9,256 feet. Yes, so after 4 seconds, the pilot's height is 9,256 feet. And you think you can answer this one? After the pilot was ejected, what's the maximum number of feet she was above the aircraft's cruising altitude? Well, you guys already know what's the max feet in general she's going. 9,256 feet. That's the highest she goes. She doesn't go any higher. What's her cruising altitude? 9,000. How can I figure out how much feet above cruising altitude she gets? Okay, there you go. The 9,256, that's the maximum number of feet she was, minus the cruising altitude, which was given to us in the problem as 9,000. So she is 256 feet above cruising altitude. How's that look, Sam? What are you thinking on this exam? Got a number for me? Like a percent? Don't be shy.
I'm going for like a 92 or more.
Okay. All right. Okay, here we go. Ready?
I can't do much worse than that. I mean, I could, but that'd be really sad.
Last one here. Last one we'll get to. Another reminder of how to complete the square. Here we go, guys. 32, please. 32. 32, complete the square. First two things I should check out before I start the process. A equals 1. What do we think? Yeah, we're good? A equals 1 and C to the other side. Look at that. Already done for you. Everything's all set. So now we can complete the square. We can start this process. X squared minus 6x plus something. Remind you and your classmates, how do I find that new C value by completing the square? Half your B value. So everyone in your head, don't yell it out. Take half your B value and then do what with it? Square it. So take half a negative 6 and then square that number. It should always be positive. And that number is 9. Unbalanced, though? Add 9 to the other side as well. So to this side, we get 24. Factor x squared minus 6x plus 9. I gave you a quick little trick there. What goes inside? Half the b value. So it's going to be x minus 3 squared. Got it? So you guys have completed the square now. You're done completing the square. You just got to solve it now. Get rid of the squared. How? Square root both sides. Perfect. Boom. What's it look like on the left side after I take the square root? Oh, hold on. Left side. X minus 3. Be careful on this side. Plus or minus. Yeah, got to remember that plus or minus the square root of 24. Get x by itself. Got one more step. How do you get that 3 over? Get the 3 over. Add 3 to both sides. X equals 3 plus or minus. Now, if you look at the directions, it just says solve. It doesn't say nearest tenth, hundredth. It doesn't say simplest radical form. But I do want to approach that right now just in case because we did skip over that unit. I say we, but Square root of 24. Anybody remember? I know I have briefly gone over this. A perfect square that goes into 24. 4, 9, 16, on and on. Perfect square that goes into 24. 4 times what? 6. So if you had to do simplest radical form, it would be 3 plus or minus, what's the square root of 4? 2 square root of 6. But hey, it doesn't say that at all. So don't try to be a hero Tuesday and do it. Okay, leave it like that. It's 3 plus or minus square root of 24.